Um, in the email I sent out two um, two diagrams, one diagram and one text sheet. The first diagram is, they called it a Maytag, but I think this was the Admiral washer back in the day. Maytag bought Admiral, and then Whirlpool bought Maytag. So this information is on the Service Matters website. I know this one image is not that clear. I wanted this image just to say, when you're looking at it, there's just so much information here, and sometimes people that are not familiar with diagrams, they look at it and they just totally overwhelmed as the amount of information that's on this, and they don't know what to do with it. I've had students. I had a guy he's worked for me and has his own business now for several years up in North Florida, and I still get calls for simple schematics and diagram troubleshooting because people just seem to have a problem understanding and reading diagrams. So I started talking this week about something called ladder diagrams, or they call it strip circuits, which is up in the upper right hand corner of this diagram here. But I want to break down the whole schematic a little bit, talk about a bunch of things, and then I'll go into strip circuits. I got a couple of scenarios, like certain things work and certain things don't. Just show you how a strip circuit can help you realize what's going on the diagram altogether. On this screen here, we got something called a timer sequence chart. That's located down here in the bottom left-hand side of this wiring diagram. Your timer's inside of this big rectangular area. Everything on the timer is inside this box. And all of those switches are listed right here in the chart. Now we'll zoom in and we'll talk about them. And then I'll just break down. Like I said, we're gonna take it little pieces at a time so that we can understand the whole circuit. One of the most important things is you have to be familiar with the components of a washing machine in order to understand the schematic. You can trace circuits, but if you don't know what a water level switch or a temperature selector switch is, the diagram's not going to help you. You have to know what those parts are. So those of you guys that just came in, hopefully, I just logged out. Oh, crap. If you guys can still hear me, give me a second. I hit something that just logged me totally out. I apologize, guys. I hit a button and sort of didn't realize that my mouse was over the browser for the Zoom meeting, or the Google Meet meeting, so I apologize there. Give me one more second to share my screen. Okay, so going here is like we were talking about the timer chart, and these components inside of here are the actual switches in the timer. So let's take a look at this, at the timer chart, and break down the different pieces of it so you understand what it is. So here in the bottom right hand corner, I have a picture of a control panel of a washing machine. And if we look at it, and I'll zoom in on it here, we have cycles like the normal cycle, they call it the pre-treat here, the permanent press cycle. These are the different cycles that the customer can select on the washer, and the timer chart is broken down by cycles. If we look here, this cycle starts right here where it says Super Wash 16, and as the timer rotates, it goes all the way over here to the off position, and then we have something called extra rinse, off, and then we got another cycle here, then off. So we have 1, 2, 3, 4 cycles on this timer that the customer can select. So let's take a look at the timer chart. And if we look at the very top of the timer chart here, now I'm not showing all of them because it's so long it doesn't fit on the whole screen. But from here, the off position, that's the off position right here on the timer. So when you start the washing machine, we're going to start right here, what we call increment 2. I know it's not a straight line, but that's would be like right here. When your arrow, this dot, is pointing right here, we're at this point of the timer chart. Now, as it starts to rotate towards the off position, if we follow this chart to the right here, we're going to see all these different things until we get to the off position. Then we have extra rinse, and if you see, we have the off position here. What does it say right there? It says extra rinse. So this off position right here would be right there. So from this point to this point is the same as this point to this point. So if you guys have any questions, don't hesitate to, just ask. Don't put it in the chat because I'm looking on one screen. I won't see your chat there. But here, if you look, the regular wash cycles from what we call increment number 2 to increment number 10. And this would be increment number 2 here. Increment number 10 would probably start right about there. So this distance from here to here would be the same as this distance here. Now, if you put the timer in any one of those positions on the chart, we're anywhere in between increment 2 and increment 10. Now, increments are, timers don't move like when you're watching a clock and you're watching the small 60-second hand rotate. It moves around the clock pretty fast. It takes 1 whole minute to go around. But how a timer advances is more like the minute hand on your clock, where it just goes click, and then it takes another minute before it clicks and advances to the next cycle. These increments are those clicks, and if we look right here, it says the interval time is 120 seconds. So that means this increment number 2 takes 120 seconds before it goes to increment number 3. So if we count how many increments there are, there's 1, 2, 3, 4, 5, 6, 7, 8 increments. How much time would this washing machine actually wash these clothes if I started right at the very beginning? Anybody got an idea?
16 minutes.
16 minutes, because it would take 2 minutes for it to advance to each one of these positions. So from here to here would be a total of 16 minutes. Now if we looked at the diagram I have right here, let's take a look. What does it say? Superwash what? What does it say right there? 16. So that means from here, not the whole cycle, from one off to the other is the whole cycle 16 minutes. But when this washing machine starts actually washing, not filling up with water, the timer don't move while it fills. When it actually fills up and starts washing from here to about this last line, just a little bit after it, right about here, is that 16-minute wash cycle. So that is what's happening on the timer chart. But let's take a look a little bit deeper into the timer chart. If I pick a spot right here, increment number, well, that's horrible. My drawing is horrible, guys. I apologize. Give me 1 second. Let's just say I go increment 3. And I didn't want it to be filled, so I won't use that one either. Here we go. Increment 3. Okay, so the timer started at 16. It clicked 1 click, and we are now in this position. So what we want to look at are these horizontal dashed lines here. These horizontal dashed lines are telling you at this very moment inside of that timer there are several switches, and these are the switches that are closed inside of the timer right now. If we follow that over to here, we can see it's switch number 26 to 28. And if you can see, this line's towards the top one. This 26 to 17 doesn't close till it gets way over here in this cycle, way over here. Then that switch will close. So even though these switches are listed here, only the ones that are highlighted are the ones that are closed now. 70 to 71, 7 to 8, 932, and 15 TM to 63, and we could just say 15. So those are the switches that are closed. If we go a little bit farther to the left, we can read what the actual purpose of that switch is. This is for agitation. This is for wash. This is for agitation, agitation, and down here is for the motor for agitation. So all these are for the wash cycle within the timer. So that switch function is telling you, okay, that switch is closed right now, and that's the purpose of the switch. And then if we wanted to, we could actually go over here and see the cams, which I'm not going to get into today. I have that in the video I'm going to upload, so you guys, if you want to check that out, that'll be up probably tonight. So far, you guys see the switches that are closed. Let's go ahead and compare it to the actual timer in the diagram. So I just copied that timer, this area right here that I highlighted in green, and zoomed in on it. So if we look here, let's go back to that same increment, increment number 3 there, and let's close those switches inside the timer. If you have your copy of the diagram, you're able to print it. Let's close it. Starting from the top to the bottom, what's the first switch that's closed here by number?
2628.
2628. Now if you guys can take a minute, can you find switch number 26 to 28? It's the 5th and 6th one here. So this switch is closed inside the timer right now. You see that?
Yeah.
Okay, so the next one is 70 to 71. So we got to find 70, 71. That's all the way in the bottom here. And that's 70 to 71 is closed right now inside of the timer. If we go a little bit lower, we got 7 to 8. Now this is number 8 here, and this is number 7 here. These little boxes that are not like filled in, that's the actual switch contact right there. We go now 932, and we're going to find 932, which is right here, and that's this switch right here. And then we got finally 15 TM to 63. Now TM, we don't have to keep saying the word TM. If you just look at number 15 here, where does it go? It goes to the timer motor, and that's why they're saying 15 TM. That 15 TM is also the timer motor. But switch 15 TM to 63 is this switch right here. So at that point in the diagram, those are the switches that are closed. We got 1, 2, 3, 4, 5 switches that are closed, and we got 1, 2, 3, 4, 5 switches that are closed. So when we're trying to troubleshoot a washing machine or any appliance with a diagram, you first have to say, where is this dial? Like, am I having a problem during the wash cycle? Am I having a problem during drain? Am I having a problem during spin? You have to look at this chart here, or this timer here, and try to figure out where it lands on the chart. So I'm going to pick a spot right here. All right, if you guys can see that. Now I'm gonna make it smaller. Take a minute and look at the timer chart and try to tell me roughly what increment am I on in the timer chart at that point. Now I'll move it over here so you can still see it. I'm gonna move my little drawing here and move it down right to there, because that's where the timer's pointed at. What increment are we in on the timer right now with the dial at that position?
13.
Yes, we're right about in the middle of 13. Very good. So if we look here, we're right here at increment 13. Right about, well, a little bit to the left of it. But that's about where we are, right here. So we'd have to go up. If I had a problem right here, let's say the customer said, the machine just stopped right there. It's not working. Well, you'd have to try to first find out, okay, where is it on the chart and what switches are in the timer that are closed? And look at this one here, 15TM66. It's not closed right there. Even this one here, 9 to 8, just turned off at the entrance of that increment. It's closed here before the rinse, but when you go after the rinse, some of them open. We only have like 1, 2, maybe this one is closed, 3, 4 switches that are closed right now inside of that timer. So you have to first try to be able to look at the dial and then go back to the chart and say, where am I on this chart? Where is this dial? So I know what switches are closed, because once I figure that out, then I can say, oh, these are the parts that are running inside of my washer, or at least supposed to be running. Now you got an idea of what's working, so you can start your troubleshooting. So we basically did that here. Let's take a look at the temperature selector switch. So we're going to first break the diagram down in pieces. So here, if you look, I got a picture of the water temperature selector switch. We got, this one isn't 100% exact, just the best image I could find. Hot, cold, which is right here, hot, cold. Warm, cold, which is here. Cold, cold, which is here. And we don't have a warm, but we have this AccuWash sensor, warm, cold, 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 and this will be warm, cold, and cold, cold here. This WW might be that one there, but I'm not sure. So anyways, first of all, what is hot, cold? What is it when you look at this knob? You're like, okay, I got hot, cold. So does that mean it's filling with hot and cold water at the same time? What do the hot, cold, or the warm, cold, what does that mean?
It's a hot wash and a cold rinse.
That's correct. So if you look right here, that's an actual key to you, okay? The first one, which is in bold, is the temperature of the water to come in during the wash cycle. And the second one, which is not bold, which is the rinse cycle. So that means the water coming in during the wash cycle will be hot. The one coming in during the rinse cycle will be cold. This one here will be warm wash, cold rinse, cold wash, cold rinse, warm wash, warm rinse. And then we have something over here called the AccuWash sensor. Now this isn't, the AccuWash sensor is more of an electronic board, but let's go to the mechanical ones. And then next week's class, I'm going to talk more about the electronic and computerized washer and how it compares. So if you look here, function of ATC. ATC means automatic temperature control. Okay, they've had these even before they had computer boards inside machines. And they wanted to make sure that water coming into the washer was a specific temperature. If you look at this ATC cold fill, that it fills with cold water, but from cold to warm in order to boost the cold wash water temperature to 75 degrees. Now, what they're saying there is, you could have a washing machine the customer selected cold, but if the water is colder than 75 degrees, it's going to actually add warm water in there to try to maintain 75 degrees or better. And the reason is, especially if you guys are up north or someone lives up north, my grandmother lives in Cleveland, Ohio, so I know what cold weather's like. And her washer and dryer are in the basement. It's not heated. So in the wintertime, it can get pretty damn cold in the laundry room. And if the water coming into the washing machine is 30 degrees or maybe 32 or higher, let's say 40 degrees, powdered detergent does not dissolve well in cold water. It'll float on top And if you don't get enough detergent, it'll stick to your clothes and it won't clean your clothes. So you have to have a certain water temperature. And the same thing is if you chose hot, they'd actually add a little bit of cold water, because if it's too hot, it's going to cause colored clothes or clothes that have dyes in them, like I'm wearing a blue shirt, to bleed. And then eventually that shirt will start to turn white because that hot water is taking the dye out of your clothes. So you don't want water too hot, you don't want water too cold. So if you look here, it says water temperature below 60 degrees, red to red is open. Well, if you look here, red to red is this. Does anybody know what this symbol is? It's a trick. It's written on the diagram. It's a thermostat. So in other words, if it chose cold, for example, we may go in through here and go through this thermostat before we go out to the water valve. And once it reaches a certain temperature, it's going to shut that off. So if a customer chose, let's see, ATC WC, 17, 16, and 19 are closed in this diagram. So let me just erase that. So if we look here, 17 to 16 and 17 to 19 are closed. So they are both going through temperature selector switches. Now this one will go this way. This one here, even though 17 to 20 is open, I don't even know why we would even, this circuit would just go this way to the water valve. And I'll show you the full diagram in a minute. So we're not using this thermostat, we're only using the upper thermostat in that cycle. If we did the bottom one, ATC CC, let me just clear it. We'd go through 17, 18, and 20. So 17 to 18, and then we go 17 to 20. So this time we'd go straight to the water valve here, but this one would go through this thermostat for the water. So if we went this way, no thermostat controlling the water, but if we go this way, thermostat controlling the water. So they use thermostats to do that. Now with your electronic machines, they have a little thermistor. I've talked about it several times, which is nothing more than a resistor that senses temperature. And when the resistance changes, when the temperature changes, the resistance changes. So that's how the temperature selector switch works. We just look at this chart here. And if I chose warm, cold, it'd be 17, 18, 19, and we just close these switches here, and then we'd have to go through the rest of the diagram. Anybody have any questions on the temperature selector switch here and how this chart works with it? Okay, so let's move into the temperature selector switch here, and let's look at this diagram. I'm going to go ahead and just we'll do the warm cold like I did in the other one, 17, 18, 19. So I'm going to close 17 to 18, and I'm going to close 17 to 19. So I'm not going to do the whole circuit. Power comes in here, goes through this one, and then this one would go back here, and that would feed my cold water valve. Notice that there's no I'm not using any thermostat here. This is just the cold water valve coming in. And then if I went down here, I go this way, and that switch is open, so nothing happens. Why am I going to an open switch? Anybody have any idea? I hear silence. Okay, so 17 and 18 is the switch that is used for the wash water temperature. If we look at 70 to, let's say, this water solenoid 71 or 72, we go back to the chart 70, 71, 72, and go here on the timer chart where it says 70, 71, 72. What does it say here? 70 to 71 is for the selection of the water temperature during wash. 70, 72 is for the rinse. So that switch is only closed when we're in the spin and rinse here. This one's closed during the wash cycle. So if we go back to that diagram, yeah, this switch is closed, but depending on whether we're wash or rinse would be where this would send power to. So the timer helps choose the temperature of the water. So if you had a machine not filling with water, it could be the water valve, it could be the temperature selector switch, but there's a timer switch in here that also has to be closed in order for the water valve to work. Now let's look at strip circuits. If we go back here, I'm going to clear it. I'm going to try to do the whole water valve circuit for you guys. What I need, someone got a question?
No.
Okay, so let's take a look at the whole wiring diagram. Right here, I cut it off a little bit trying to get this to fit on the screen and also be clear enough because sometimes I screenshot it and it's blurry. That's the power coming in. Line 1 is here, which is black, and neutral's here. So the power's got to come here and go back out there. It's got to go in this way and out that way. So let's get the timer switches that are closed in this increment 10. Can someone read them to me so you know what, I got an idea. They don't have to read them to me. I'm going to select this, and then I got the switches that are closed already. I just carried it to this one, put it right here. Well, actually I could just put it right on top, right? One second. Trying to make it fit on the diagram, it's not going to fit too well. That ain't going to work. All right, we'll just leave it on the left side there. Okay, so if we look here, we had 2628 closed. So we had this one closed. We had 15 to 63 closed, this one here. We had 8 to 7 closed here. 932 here. And we had 70, 71. So before we go and complete our circuit, look at our water level switch here. We have the word empty, we have full. What position is this switch right now, the contacts that are closed, what position is it in? It's empty. When you first turn the washing machine, it has no water, so it's empty. So that's the position from 11 to 2, or from gray to orange, it's closed. So let's go ahead and I'm going to highlight that circuit for you of how power is coming in and feeding the components in the machine. So I'm going to come in here. I could go down here, but look, there's no switch closed off of this 27, so I'm not going to go down there. I'm going to go here. Guys, when you see this line around the timer is just saying everything in the box is a timer. We don't hit this line and go up and follow that line around. We got to stay on the actual circuit, and it goes 2628. It comes here, and the first thing it does is go to the water level switch. Since the machine's empty, we're going to follow that switch to the left and complete the circuit for our water valves. Now we have to close our chart here. Let me move this out of the way. No, I can't do that. I can move that out of the way, but I just got to delete these. So let's go ahead and just pick warm cold. All right, we're going to go ahead and pick the temperature selection warm cold 17, 18, 19, 17 to 18, 17 to 19, and let's complete our circuit. We come in, it goes up here, and then it goes like this, and guess what? This switch is not closed, so we're going to go here, over, and we're going to feed the cold. But I have warm cold selected, don't I?
Mm-hmm.
So if I go through this chart here, the only way I can go through is down. I'm going to follow that up here to the timer chart, and it gives me two options. One, to go back to my temperature switch, or two, to go up here and fill my hot 2. So now both water valves are energized. We're getting warm water, and I'm just going to follow this circuit out. So that is the circuit for the water solenoid. Now, the reason I brought it up is because I'm going to go to the strip circuit next, but I first wanted to complete this circuit. But before we do, we still have 3 switches in our timer that are closed. Did I miss something? Did I not complete a circuit that I should have? I mean, those switches in the timer are closed. Why are those switches closed?
Would this be the first part of the cycle, or the first? So you're in the first, what, 1 or 2 increments?
We're
so
at,
the others wouldn't energize until after.
well, yes, we're in this same increment here, number 3, and when those switches that we picked at the beginning, I went ahead and closed them here. You're sort of right what you said, but not exactly what I was trying to get at. What do these switches go to? If I followed this switch, what is it really doing? It's feeding my motor, right? This is my motor here. But what's the machine doing? It's filling water. Does a washing machine agitate? We're talking about a top loader now. Does a washing machine agitate while water's coming in?
No.
No, it'll damage clothes if it does that. So if we look and follow this 1563 backwards, where does it go? It goes to my water level switch. So it's waiting for the water level switch to say, hey, I got enough water in there. Now you can start washing. So there are switches in a timer that may be closed. It does not mean those parts are running right now. They're waiting for some other component in the circuit to feed it. Now, if I told you I picked warm cold on my washing machine, but I only got cold water coming in, could you look at this diagram and tell me what parts to check?
Yeah, you'd go backwards from your hot water valve. What did you check last?
Okay, but what specific things would you test out of this whole
17.
circuit? Go ahead, I'm sorry.
It'd be like 17 to 19.
Okay.
Trying to see, it's so small.
I have it as big as I can on my screen, sorry.
Okay.
That's why I put the diagram so you guys could print them out.
Yeah,
And have...
I printed it, but I printed it small myself.
Oh yeah, it is even small. You have to actually tell your printer to zoom in on
I
different
blew it
parts.
up. Yeah.
Yeah.
Because I could, but then I started running out of ink.
Yeah. So if you look though, that's okay. But what I would normally do if I had just this diagram is I'm going to take an eraser and say, my cold water works, right? I said the cold water works. We have no hot water. So I'm going to erase the circuit that feeds the cold water.
Yeah, because that's working.
That's working. So watch, I'm going to erase this going back to neutral because I know the cold water's working, right? Now if I follow the cold water line back this way and erase all this here.
Yeah, that's for the warm circuit.
Well, not just the warm circuit, because the warm circuit also used what I'm erasing now. They're both using these same things here. But now I separated the cold and the hot, the differences between the two.
Yeah.
And the only thing we got is the cold solenoid, 70 to 71 in the timer, or 17 to 19.
17 to 19, yeah.
Yeah.
That's what I was saying, backwards, yeah.
Now that's in a diagram, but people still have a hard time when they're looking at all these damn lines and they're like, man, I can't stay on it. I can't trace it. I can't follow it. But if we look at these strip circuits, what they do is they're telling you wash, fill hot water, fill with warm water, with ATC, fill with cold water. So each one of these circuits are just trying to show you, like, okay, if this was the hot circuit, if I was just doing the hot came in, went through here. I'm sorry, I went too far. The hot came in, went here, went here. This is the hot circuit that's not working.
Mm-hmm.
And as a technician, when you go to a machine and a certain part of the machine's not working, you want to go to this diagram and you want to see the circuit of that part that's not working. And you could check everything, but you know, we're going to check 11 to 12 in the water level. We're going to check 26, 28. The reason why I erased that circuit prior is because I know 26 and 28 is good because the cold's working. But in a strip circuit, they take that hot water and said, this is the hot water circuit here. These are all the things that the hot water valve needs. Here's the water valve. We got 70, 71, 17, 19, 11, 12, 26, 28. The same switches we just pointed out. But if we could even take that a little bit further, look at these two here. Cold water works, but no hot water. So now what I did is I just took out the strip circuit for the hot water valve and the cold water valve out of that big chart. And let's look. I said the cold water works, so I know 26, 28 has to be good, but guess what? The hot uses 26, 28 also. I don't need to check it because they're using the same switch. I know this one's good. What about the water level switch?
It's working.
So I don't need to check that. How about 17 to 18?
It's working on the cold.
But we're using what on the hot?
17 to 19.
Okay, so it's different. What about this timer switch 70 to 71? What about the cold?
It doesn't use it.
It doesn't use it. So these are the three things you test. You can see how a strip circuit just makes it so much easier. It's just in a straight line. And if you can compare a circuit that's working to a circuit that's not working, without even putting a meter on it, now you only have three things to test. A temperature switch, a water valve, and a timer. First thing I'm going to do is see if I got power here. And if I have power here, the water valve's bad. If I don't have power, I'll check the water level switch first. If the water level switch is good, most likely my timer's bad. But those are the only three things it could be. So remember, if you can read the wiring diagram, you could narrow down what is good and what is bad before you make a test. If you can compare these circuits, and that'll reduce your time it takes to troubleshoot. A lot of people, when they go up to a machine and the machine's got no hot water, no cold water, they understand hot water don't work. And this was really something that came up to me when I first started working on appliances. Is I'm like, I get it. I know how to check a timer. I know how to check a water level switch. I know how to check a water valve. But I go up to a machine and this is not working. Where do I begin? What's the first thing I got to do to troubleshoot that problem? And the first thing you got to do is first go to this timer. Find out where in the timer dial you're having the problem. Then you're going to go to the chart to see what switches in the timer are supposed to be closed, so they tell you what should be running when you're having that problem. Do you follow me so far?
Yep.
Okay, so once you do that, and we find out the switches and we close those switches, which is the next step that we did, I added the temperature selector switch in there too. Then we come here and we find the circuit for that part that's not working. Once we find the circuit for the part, I don't necessarily myself need the strip circuit. It makes it easier, but I can look at what I highlighted and tell you what switches I need to check in my machine. So this is answering that question. Okay, I got this problem and this is not working. What do I do first? How do I check it out? Where do I begin? And so that is the beginning of troubleshooting. And the only thing is that these strip circuits, what they do is, if you said the hot's not working but the cold is, they break it down and say, Well, if the hot's not working, but the cold is, this is the cold circuit. This is the hot circuit. I don't need to check 2628. I don't need to check 1112. But this is different. This is different. This is different. And those are the three parts I would test. So you see, even when we're troubleshooting with a meter, what are we doing? We're checking a door switch and it checks good. Then we're going to a water level switch and it checks good. Little by little, we're eliminating things that could be a problem. Using a diagram helps you eliminate them before you even open the machine up and actually put a meter to the components to test them. It's going to reduce the time it takes you to troubleshoot. So I got a problem here. You guys try to figure it out using the strip circuit. Washer fills but does not do anything else. So take a minute and look at this strip chart and try to figure out what could cause those problems. What components will we test? Trying to make it a little bit bigger, but about the best I could do here, guys. What would be the first thing we did?
Well, the washer's filling.
Okay.
So 26 and 28 is working.
Okay, so if it's filling, just like I did on the timer, we're going to highlight this circuit, right? I'll just do these two. Okay, this is the water valves here. All these, the cold, hot, whatever. These are all your water valves here. What are the circuits below? Motor agitate fast, motor agitate slow, start, whatever. The timer, a timer advance, and everything else. But I'm telling you that the machine filled up with water, and this is what you saw when you went to the customer's house. Machine filled up with water, and this timer was sitting right here. It has not moved. Lady said, I put it right there. I pulled the knob out. Water started coming in, and then it just sat there. It didn't do anything else. I couldn't get it to drain. I put it in the spin cycle. It didn't drain. I put it to the rinse cycle. No more water came in. It wouldn't agitate. It wouldn't drain. It wouldn't spin. So the only thing I know is water came in.
Now you had a part on one of those screens where once it filled up, it had to go over to the motor.
That's correct.
Where's that part of the schematic?
Well, that's the water level switch right here, right? Yeah. Isn't that the water level switch?
And then it didn't go to the motor.
I'm sorry. What are you asking here?
You had a part where you said that no, could you go to the other one? No, that one.
That one here?
No, that one. It went over to the motor from.
Yeah, from number 14 off to
14, yeah.
Off to this.
Mm-hmm.
So if it filled, that means everything in green now is good? If water came in?
Yeah, that would be good because it filled up.
There you go. So
mm-hmm.
I wanted you guys to think a little bit. I don't want to just sit here and talk and tell you what it is, because if your brain's not thinking, you're not doing anything. So before we tried to figure out what was wrong, we had to see what was good, because if this is working, what I have highlighted in green, I'm not going to check 2628, right? So if we go to this chart here, we use 26 and 28 here for the starting of the motor, right? We use 2628 for this motor here, which this is the start and the run winding. They just broke it down in separate circuits, but I don't need to check them. So that is a way of troubleshooting where we're reducing. But now one thing we have to look at is if the washing machine's filling, what parts are not working? If you're just thinking and said, okay, I got water coming in, nothing else working, what parts of the machine are not functioning?
the motor's not working.
Okay, so we have here the run winding of the motor that's just fast and slow. Start winding of the motor.
Yeah.
This is also the motor here for spin. This is the timer motor, but is the timer advancing?
No, it's still in the same spot.
No, I told you, yeah, the customer filled with water and the timer was at that one point and the timer never moved. Okay, so now that we identified the parts that were not working, the motor, the start winding, the timer motor, instead of looking all the way over here, what we want to do is look for what parts do they all have in common, because if that one part failed or this one part failed, that would stop all those pieces from working, right?
Mm-hmm.
So looking at the diagram, starting from the right-hand side, what one thing would stop the motor and the timer from running?
Door switch.
Okay, the door switch. And if you see how the strip circuit says, hey, listen, all these parts down below, they all got to go through the door switch. Does my water valve go through the door switch?
No.
No. What else?
Is that right there? Yeah.
What is that? Oh, you gotta know your symbols. That's your motor protector, or also known as your overload in your motor. Now guess what? Your timer, the timer motor goes through your motor's overload. Let's go back to the diagram. If I looked at the timer motor circuit here, and let me try to clear this for a second. Let's see. I don't want to lose the switches. 8, 7, 32, 9, 15, 63. 15, 63, 8, 7, 32, 9. I think it was 26, 28, right?
Yes.
Okay. So if I wanted to just do the timer motor circuit, let's just see how the timer motor gets power. We go through here. Timer goes through here. Got to go through the water level switch when it's full. And when we hit 15, we go down here. And then the timer motor follows this line here for neutral and goes back to the motor and goes through the motor overload, which is right there, and the door switch. Now, if I did a different circuit for the motor itself using the same line, like this, but my motor, I had to go to 1563, and I'm just going to pick a motor speed. I'm going to go through this bottom one here. Now look here, you see this 32? It's connected to this 32 here and goes to 9, which is my capacitor and start winding. It goes back out. This, I know it's a crazy line. That's the start winding. And out. Now I just got to do my speed, which is my high speed and my low speed. And if I came here, how am I going to feed that high speed? If you look here, 32 went down. 32 also goes back here on this yellow and goes up and over. So if I erase the black and green lines together, the ones that overlap, those are the circuits that are working, because we said the green is where the timer motor was. Then you could say, oh, the timer advances but the motor don't work, and I would say the timer circuit is here. So then here I got 1563, 932, speed selector, and the motor. I've just eliminated a bunch of things in that diagram. Now let's go back to the problem we had here. The door switch controls the motor and the timer. The timer goes through the door switch. Believe it or not, Maytag used to create a rinse cycle, like a pre-rinse. You turn the machine on and let it fill up with water. If the customer left the lid of the washing machine open, it allowed the clothes to soak for as long as they want. before they closed the lid, and then the timer and the motor would run and actually wash the clothes. So they could create a manual pre-rinse just by leaving the door open, because the timer won't work here or the motor when the lid's open. So the overload protector could be bad, and that would stop the motor, but guess what? It will even stop the timer. Are there any other switches on this side that both the motor and the timer share?
No.
Well, maybe 2628, but we said the machine filled, and what did it say about 2628 then? It's got to be good because it's filling. So there's nothing on the left-hand side that would cause my problem if the timer motor didn't work. It's just the door switch or the overload. That's it. It's the only thing left. So if you learn to look at the strip circuits, all they're doing is they're taking these wavy lines on the schematic. Here. These wavy lines, and just making it in a straight line, easier for you to see. Now, in the handouts that I sent to you guys in the email, they have the VMW washer, which in the manual shows strip circuits for those components. And so what I'm going to do in next week's class is I'm going to go through that manual and break down some of the strip circuits, but we're going to look at the main wiring diagram, and we're going to look at the strip circuits, and we're going to also talk about, okay, what things do they share and not share by looking at the strip circuits. So strip circuits are really put on machines only to help break it down. Some stoves, let me see something here. Sorry guys, just give me a minute to find this one wiring diagram on the machine. No, not that one. I have it. I'm trying to find it here. 1 second. That's a guess. Of course, you know, I'm not going to find the one I'm looking for. Okay, this one might work. Let me see. So if you look at this one, this is similar to, this is what we call a pictorial wire diagram on this stove. And this diagram on the right hand side is the same diagram on the left hand side. We got our 5 burners, 1, 2, 3, 4, 5 burners here at the top. Well, I'm going to zoom in on it because I know it's very hard to read. But if we look at this diagram here, we have 1, 2, 3, 4, 5 burners there. If you look at the wiring diagram of the stove, isn't it almost like a strip circuit?
Yeah.
So they made it a little bit easier to read by drawing it straight. The only difference is they don't have no colors of wires on this diagram. So what Frigidaire would do is they would create a pictorial diagram over here, and I know it's very hard to see, sorry guys, but I'll make it real big if I can, but it'd probably still be blurry. But these little oblong things are the color codes. Purple, there's BL, I can see red, white there. So
you have to jump between both.
Yes, you have to learn this if you want to come over here. You don't know the colors of the wires going to the components. So what I'm going to do is I'll email you out a couple of questions this week. Let me put some questions together using this diagram and see if you guys can answer those questions at the beginning of next week's class if you can attend. And I know that this week wouldn't be normally a class, but coming back from the trip I didn't have time to put together a presentation. That's why I put it on this week. But next week, Saturday, I want to compare this to the VMW washer that you guys got in your email. I want to talk about strip circuits, but I also want to put some questions related to this machine, telling you, oh, this works, but this does not work. And what I'd like you guys to do is just say, okay, well, with that problem, it could either be door switch or motor overload, or this problem could just be the water level switch in the full position. Okay? So we're going to try to work towards more diagrams and troubleshooting in the next couple of classes. Does anybody have any questions for today?
No.
I don't have any questions, but this is exactly the kind of content I'm looking for, so I really appreciate it.
Well,
you're gonna
get
exactly what I mean.
Yeah, you're gonna get a lot more of this because my class, and I've been getting a lot of calls from people outside that I know they're asking me for help, and I was like, man, let me spend a little more time doing diagrams, troubleshooting. Listen, the more you look at these, the easier it's gonna get. And so, like I said, I'm going to create some things that I want you guys to at least to practice with during the week, so that next weekend, about the same time, I'm going to give the next week's class as well, and we're going to do some schematics. And I'm going to have Brandon do some schematic and troubleshooting on other machines as well, just to get you guys immersed into these diagrams to make your life easier.
Question, Mr. Rick.
Sure.
With what you just did, also, could you incorporate the testing from the board with something like this, what you just did?
Yes, I could. Maybe what I'll do is next week's class is going to be more like this one. But what I'll do is I'll work on getting a VMW washer from class. And I'll do a lecture in my class using a diagram and testing those same strip circuits from the board, but I won't post that video till after Saturday's class.
Okay, awesome.
All right, guys. But also, I put out that Maytag washer, like how to go into diagnostics and troubleshooting. My goal is to go over all the different washers in my class. Is like my next project, and I want to go through each one and go through the diagnostics and talk about how to use the diagnostics for troubleshooting. I just got to find a better way. A better camera that will project it onto my board and won't be so blurry. I was sort of upset how bad that quality came out, but it was just because that camera. I'll figure out a way to make it better. But I'm going to create a series for members in the members section on videos on troubleshooting washers using diagnostics, and it's just going to have Maytag, Amana, whatever machines I can get my hands on, make a video on each one on getting into diagnostics. And then I'll create a link to the actual technical sheet that goes to that machine so you can download it. And I'll show you how to get into it. But I'll also talk about how do we use the troubleshooting of the circuits, like using the diagnostic tool, to actual troubleshoot a machine. So that's also part of what we're doing here today. Other than that, guys, it's 1 o'clock. I'm going to stop the